Okay, hi there. So what we're going to start doing is we're going to start looking at and talking about the zeros of a polynomial. And so to start with, well, in mathematics there are a lot of applications of polynomials. And so it's important to be able to find or approximate the zeros of polynomials. And so that's what we're going to start focusing on in this section here. And we're going to start talking about the rational zeros theorem. And so the theorem states that if we have a polynomial, and like this, right? So we have a sub n times x to the nth power plus a sub n minus 1 times x to the n minus 1 power, all the way down to the constant term a sub 0. And if f of x has integer coefficients, okay, so that's, okay, so again, stipulation here, condition, okay, and a sub n is not equal to 0, and if p divided by q, and again, we're assuming this is in lowest terms, so this is a simplified fraction, is a rational zero. So if p divided by q is a rational zero of the function f, the polynomial f, then we can know that p is a factor of the constant term a sub 0, q is a factor of the leading coefficient a sub n. Okay, so let me say that again. So the rational zeros theorem says that if we have a polynomial with integer coefficients and a sub n is not equal to 0, and if we know that p divided by q in lowest terms is a zero, a rational zero of the polynomial f, then we know that the numerator has to be a factor of the constant term and the denominator has to be a factor of the leading coefficient. Okay, so now how does this help us? Well, it doesn't help us directly in applying this theorem because this assumes we know p over q is a zero. But it does help us in finding possible candidates for being a zero, a rational zero of a given polynomial. Because now what we can do is we can kind of like work backward and say, okay, if I start by taking all of the factors of a sub 0 and all of the factors of a sub n and creating all possible fractions of p over q, then that'll give me a list of all of the possible rational zeros I can test. Or maybe, or cycle through and find one, right? Now, there's no guarantee that I'll find one. I might go through the entire list and come up short, but at least it'll give me a starting point to test. All right, here we go. Do some examples now.